I'm looking forward to doing a great set of interviews today ahead of OFC. We're looking forward to seeing live demos, live technology, especially around 800 gig and silicon photonics. I'm Alan Weckel from 650 Group. We do market research in these areas, and we have a great set of speakers lined up today to kind of give a preview of OFC.
Hi, Alan. How are you?
Hi, Hamid. Great to see you virtually. Looking forward to seeing you in person at OFC. Can you just give a quick background about yourself and Ranovus, and then I'll go into some questions for you?
Sure. It's great seeing you, Alan. My name is Hamid Arabzadeh. I'm the CEO and chairman of Ranovus. At Ranovus, we build high-capacity optical interconnects for data center applications for AI and machine learning. OFC has been a fantastic playground for all of the optical technologies, and there's a lot of industry firsts being announced there. Last year, we had our co-packaged optics 2.0, which we announced at OFC, which was co-packaging optical technologies with a switch chip, and we're looking forward to our announcements this year at OFC.
Great. Can you talk a little bit about the importance of CPO and kind of onboard optics co-packaging for the industry?
Modules have been around for a long time, I guess probably about 2 decades or so, and they've served us very well with modularity, low power consumption, and ways for us to disaggregate innovation from switches. As we go forward, the capacities that are required for these modules and the power consumption constraints that they have for Ethernet switching and other applications has brought us to a place where we have to start eliminating some of the components like retimers and the like. So co-packaged optics brings the optical engine, the core piece of innovation in the module, close to the switch chip or other processors, GPUs, FPGAs, and the like, to have a very low power consumption. The promise of it is that close to 40% power consumption reduction and 40% cost reduction versus the modules.
Got it. That sounds really exciting. Can you talk a little bit about what's kind of changed now versus a couple years ago with the technology, and maybe talk a little bit about what you're going to be demoing?
Yeah, I think the biggest breakthrough came with silicon photonics, having a way for building optical technologies using silicon, a $1 trillion industry behind it. And foundries adopting this type of technologies and making it mainstream. If you look at few foundries right now that have stepped up, Intel, Global Foundry, Tower Jazz, TSMC, and you have very big names. It's not a boutique industry anymore. And as such, this has transformed the level of investment that has gone into the process development, and it allows companies like ourselves to be able to do innovation in our platform, which we're announcing, the co-packaged optics, the Odin platform, which is a monolithic chip. And this was never possible to have optical and electronic components in a single die before we embarked on this roadmap. So we have 2 announcements. One is a customer announcement with our product, and one is a technology announcement around Odin and our platform technology that we're going to be sharing with you at OFC.
Great. And maybe you can show one of them to the audience now as we go and talk about kind of the first application.
Yeah, so this is a switch application. We did this model, and these are the optical engines. It's the CPO 2.0. There's an analog interface between the 2 chips. There's no retimers in these. When you look at the optical engine that is inside, this is a 800 gig version of the optical engine, and we have the 3.2 terabit version. You can have it. It's in the same footprint as this one. And you can see the electrical signals come here, and the wavelengths and the optics signals go out from one side. So we're just converting the electrons to photons using these platforms. The power consumption for the 800 gig version is only 4 watts, which is industry's first. And this has been achieved through our monolithic technology, where our EPIC, which is the electrophotonic integrated circuit, is a single die with our lasers, our own Ranovus lasers on that die. So it's a very compact and miniaturized solution for co-packaged optics.
Great. Well, Hamid, thanks so much for the time today. Looking forward to touching those products in person at OFC. It's going to be great to see these things and actually get our hands on them. So thank you.
Yeah, thank you very much for your time. Take care. Bye-bye.
Hi, Robert. Great to see you virtually and looking forward to seeing you in person. Can we start with a little bit about yourself and Intel and your kind of what you're expecting to show at OFC?
Yeah, hi, Alan. Of course, we're also looking forward to meeting in person again after 3 long years of not having hosted or participated at OFC. We have a nice booth. We're looking forward really for everyone to come together at the booth and meet with customers and ecosystem partners and suppliers. We have several demos at the booth, both on the silicon photonics side, on our intelligent fabric processor and Ethernet switch side, and also with our FPGA portfolio. So we're quite happy and excited to have live demos again and meet in person at the booth.
Okay, let's dive right into that. So can we talk a little bit about silicon photonics and how you see that market transpiring and also what you'll be demoing at OFC?
Sure. I mean, we see this continued growth in bandwidth, obviously. So, when we started with Intelligent Photonics, we had 100 gig transceivers, and they're still alive and well and shipping in high volumes. But now, obviously, we've started deploying 200 gig and 400 gig optical transceivers. And now we're also demoing at the booth 800 gig pluggable transceivers, particularly in the OSFP form factor. These have 100 gig electrical SerDes now. So this is quite exciting. So we're moving now from 50 gig electrical SerDes to 100 gig electrical SerDes ecosystem. And obviously these then plug into 25 terabit switches, which also support these 100 gig SerDes. So we have a demo at the booth with some of our ecosystem partners to show the maturity or the growing maturity of that ecosystem.
Great. And Intel also has a great set of networking products as well. So maybe we can dive in there to what you see happening in networking.
Yeah, absolutely. So we have our Tofino 3 intelligent fabric processors. And if you think about what's really happening in the data center of the future, you really have general purpose compute, you have accelerators, AI machining, learning accelerators, GPUs, storage, and they all need to be connected, talk to each other, right? And so we have this intelligent fabric at the center of the data center, right? And so that's really key if we look at the evolution of the data center. And we'll be demonstrating our 25T switch platform based on our intelligent fabric processor, which also is a modular platform with either 56 gig or 112 gig SerDes. So you can mix and match and basically configure that for the growing demands in the data center.
Great. So it sounds like higher speeds in both those areas, talking about 800 gig and 112 gig SerDes. What about the FPGA? What are you going to be demoing there at OFC?
Yeah, it's very similar there, actually. So we have our Agilex I series FPGA, and we have, if you recall, these high-speed tiles in that FPGA. And so we have new F tiles that are supporting 4 ports of 100 gig each. So we have actually Agilex I FPGAs, which have 2 tiles for an aggregate of 800 gig as well. So we have basically 8 ports of 100 gig going in and out of the Agilex FPGA series. So, very much the common theme of 100 gig SerDes are here now, and the ecosystem is really coming together to again support the growing needs of the data center.
Great, Robert, thanks so much. I'm looking forward to seeing these products in person. It's going to be great to see all these different higher speed products and actually get our hands on them. So thank you for your time.
Indeed, looking forward to seeing you soon, Alan. Thank you.
Hi, Nathan. Thanks so much for spending time with us today. Could you just give a quick little background about yourself and the OIF, please?
Hi, Alan. As you mentioned, I'm Nathan Tracy. I work with TE Connectivity, where I'm a technologist on the system architecture team. And TE is a member of an organization called OIF. Currently, I am on the OIF's board of directors, and I serve as the VP of marketing. Previously have filled many other positions, including president. The OIF is a global organization consisting of over 130 members, working collaboratively to address interoperability gaps in the industry. So someplace in the network, there's applications or opportunities to be improved or optimized or benefit from an interoperable solution. And that's what the OIF does, is they come together, talk about what that gap is, what are the best ways or options to address it, and then write a specification and then make it publicly available for the industry.
Got it. Great. Nathan, at OFC, OIF always does a great job with demos. So can you talk a little bit about what you plan to be demoing and let us get our hands on this year?
Sure. I'm really excited to talk about that, Alan. At OFC this year, we are going to have our largest OIF demo ever. So we have 29 member companies participating in the demos. We're covering 5 different technology tracks. So this is going to be a very exciting demo for us. The demo space that we've arranged is booth 5101, right at the front of the hall. And it's a 20 by 30 booth. So you can imagine that we're going to have a lot of exciting things in there. The 5 technology areas that we're going to include are 400ZR. So this will be the first public 400ZR interoperability demo. And we're going to have a number of members representing multiple module makers, router providers, open line systems, test equipment vendors, all providing a range of performance over 80-kilometer links on a DWDM ecosystem.
Got it.
The next one I'll mention is the CEI 112 gig demo. So CEI stands for Common Electrical I/O, and this is a specification that the OIF has been publishing and updating for over the past 20 years. So going way back to sub 1 gigabit per second, we have provided this channel definition. So transmit specifications, receive specifications, and channel requirements to enable an interoperable ecosystem from SerDes to SerDes. So this has kind of been the Bible that the industry marches to. We published a superset of specifications, and then the industry, various different standards, consortia, take the portions of that CEI spec that's suitable for them, and they run with that. For this year's demo, we'll be featuring CEI 112 gigabits per second. And we have over 12 members participating in various different demos where we're going to be showing silicon interoperability over multiple different channels for the VSR, which is the chip to module, MR, which is medium reach, like a mezzanine card application, and then LR, so a backplane or a direct attach copper cable. So we'll be showing that demonstration as well. A very exciting topic that the OIF has recently become involved in the last 2 years is providing standardization for co-packaging. So we've done a couple industry webinars over the last couple of years on this, and now for the first time, we're going to come out and publicly show some of the work that we've done. So specifically, there is a project to define a co-packaging framework document, and that was just recently published. So we'll have that at the show. In addition, we're defining a 3.2T module that can be either optical or copper cable that can be used in a co-packaging application, and we'll have a static display showing what that equipment would look like. And then we will have operating demos for our ELSFP demonstration. ELSFP is external laser small form factor pluggable. So this is an external laser module definition for faceplate pluggable modules that enables field servicing of external lasers that would be necessary and used for co-packaging architectures.
Great.
And then the last two that I wanted to mention are a little bit different because they're a little bit less hardware focused. They're more along the lines of software or firmware. And that is, the first one is the CMIS, Common Management Interface Specification. And this is an activity that was initially documented by the QSFP-DD MSA, and they have finished their work. They've transferred it over to the OIF, and we are now taking that on in the OIF and doing extensions onto that specification. And in that demo, we'll actually be showing three things: how to manage and initialize a module when it's plugged in. We'll be showing how we can optimize for functionality, such as a point-to-point link or a breakout type of application, and also be showing how we can do module firmware updates as well. And then finally, the last demo is the FlexE demo. So FlexE is Flex Ethernet, and they will be showing off their latest FlexE 2.1 revision. And they'll have a demo that will show bonding, subrating, and channelization as enabled by the FlexE specification. So it's going to be a very full booth, a lot going on, and all of it is really groundbreaking work in terms of bringing interoperable solutions to the industry.
Great, Nathan, thanks so much for your time. We appreciate it. It looks like I'm going to be spending a lot of time seeing a lot of products in your booth, and that's always a great thing. So I'm looking forward to getting my hands on them and seeing you in person.
Yeah, no, it's going to be a great show. And there are two OIF papers or market presentations being given as well. One on the CEI work, where we will start to talk about addressing 224 gigabits per second, and one on 400 ZR and the work that is now started to establish 800 ZR definition as well. So, I hope that you're able to catch both of those sessions also.
Great, will do. Thanks so much, Nathan. See you soon.
Okay, thanks a lot.
Hi, Dan. Great to see you virtually. Looking forward to seeing you in person at OFC. Can you give a little bit of background about yourself and maybe a little bit of highlights? There's a congratulations in order now that AMD and Xilinx are together, and I'm sure we'd love to hear a little bit about that.
Great, Alan. Thank you very much. I'm responsible for marketing in the communications group. And at AMD and Xilinx, we're super excited that we've actually integrated as one company. It's historic in the fact that it's the largest semiconductor acquisition at about 50 billion on a market cap level. And it's really exciting to bring together compute, GPU, and adaptive SoCs under one roof, where we can really innovate on some of the solutions that are tightly coupled or increasingly tightly coupled, as well as the software model. And that really counts from games to life-changing surgery. So it's exciting that we're really solving some problems and have the scale to do that.
Awesome. So let's dive right into OFC and maybe give some hints about what you'll be announcing there. And let's talk about 800 gig and everything from 100 to 800 gig and what you'd like to share with the audience.
Yeah, we'll be showing quite a few demos of really bringing out our new 800 gig. And actually, we go from 1 to 800 gig, and we'll show multiple types of 100 gig. We bring out two new hard blocks in our platforms, ASIC constructs for both multi-rate MAC as well as a 400 gig optimized block. We'll be showing that at 800 gig rates coming into our device and a total throughput of 5 terabits, and really being able to operate with many partners at OFC. So we'll be showing live demos. We're shipping that product now. It's in our 7nm Versal premium product.
Great. All right, and next question, what about co-packaging? There's going to be a lot of announcements at OFC there, and I know AMD is super excited about that. So what would you like to share about that?
Yeah, and the industry is really doing a great job of innovating with co-packaging. We'll be announcing with Ranovus a new co-packaging at 800 gig into our platform. And really, it enables us to show how we can use multiple different types of protocol to really innovate interconnectivity, whether it's PCI-centric or Ethernet-centric or proprietary low latency. You can really do a lot of new applications connecting all that compute we talked about.
Great. And security is a theme in all these things. So how does security play for you at AMD?
Security is pervasive at the device level, at the system level. We're coming out with a whole bunch of new products that have a deeply embedded crypto block at up to 400 gig rates that can be decomposed at different rates. And we can really do line rate up to, in our largest devices, 2 terabits inline crypto processing.
Great. I'm looking forward to seeing these demos live and kind of getting my hands on this hardware. So looking forward to seeing you soon. And thanks so much for your time.
Well, thank you, Alan.
Great. Well, thanks, Ranovus, Intel, OIF, and AMD. We heard a lot about 800 gig co-packaging, and I think this year's theme of OFC of these companies is going to be a lot of hardware demos on next-gen technology and actually seeing live traffic on these products. So looking forward to getting our hands on them in person. And thanks so much, everybody, for participating in our video interviews.